Alrighty, everybody, we're going to get started with our first review lesson, which is focused on factoring strategies. Factoring strategies is one of the most important prerequisite skills that you should have developed in both grade 10 and grade 11 math that's going to ensure that you're successful in this course. Our first strategy is common factoring, and even with the most complex problems, you want to see if you can common factor first. I always write this little acronym CFF, common factor first, as a reminder that that's what I should be checking for all of my problems. Essentially, with common factoring, you're looking at across all of the terms, what do they have in common? You're pulling it out, and we are writing our answer as a product of the different factors. In our first example here, 5x plus 25, I can factor out a 5 from both terms, and I'm left with an x plus 5. In our second example, I'm going to be factoring out, I'm going to be checking against both the coefficients and the variables. My coefficients have a common factor of 4, and my variables have a common factor of x. So I'm going to pull that out, and what remains is a 2x plus 3. In the last example here, once again, I'm checking against both the coefficients and the variables. I can see my coefficients have a common factor of 5, while my variables have a common factor of x cubed. Basically, it's whichever x has the smallest exponent. Remaining in my brackets will be a negative 2x to the power of 4 plus 3x squared, and then take away 6. My last term no longer has any variables remaining because I factored them all out. The second strategy we're going to work with is factoring by grouping. This is a great one to tackle to help you tackle some more complex trinomials. Essentially, what you're going to be doing is you're going to be dividing the terms into two different groups, okay? And I'm going to show you what that looks like in our first one here. We have something weird going on. We've got 3x plus 6, take away 4xy minus 8y. No idea how to handle this, so quite literally what I'm going to do is I'm going to separate this into two groups. My first group will be the first two terms, and then my second group will be the second two terms. My second step now is to common factor each group so that I have a common polynomial remaining. What does that look like? Well, let's just look at our first group here, 3x plus 6. I'm going to factor out a 3 because it's what they have in common, and then what will remain is x plus 2. So that is the That is the corresponding factor, or factored form, I should say, of the first two terms. For our second two terms, I'm going to see once again what do they have in common. It looks like they've got a negative 4y in common, and then remaining is going to be x plus 2. And so that is the factored form of my second set of brackets. Now remember when I said they have to have a common polynomial that's remaining? Well, take a look. X plus 2 and x plus 2 is identical. That is the common polynomial remaining in each of the groups. What this allows me to do is I can literally now factor out that common polynomial. So I can say, well, they've both got an x plus 2, so I'm going to factor out x plus 2. And then what remains now is going to be all of the stuff on the outside. Let's see if green shows up. Yep. So the stuff in the green is now going to be what I put in my second bracket. 3 take away 4y. This is the stuff that was on the outsides. X plus 2 was the stuff on the insides. Let's do it again. Question B. Tx take away px plus ty take away py. I'm going to split this up into two groups. I have my first group and my second group, and I'm going to go ahead and factor them. Across the first one, what they have in common is an x. What remains in brackets is t minus p. And then in my second set of sort of terms there, my second group, what they have in common is a y. And what remains in brackets is going to be t minus p. Once again, that common polynomial, t minus p, is in both of them. I can finish it off now by factoring out a t minus p. And then in the second bracket is going to be everything that was in front of them. So x plus y. And we'll do one last one. This is a little bit larger, but same principle. Let's take a look. I have my first two terms are going to be in one group. My second two terms are going to be in the next group. What do they have in common? 3x, bracket 2x plus 3. And in the second set, or in the second group, what they have in common is a 5z. And what remains is 2x plus 3. I factor this correctly now, as both of them have a 2x plus 3. So I'm going to pull out 2x plus 3. And what remains in my second bracket will be 3x plus 5z. Okay? Great way of tackling some more challenging ones. Our next two strategies involve trinomials, and this is where, this is what you should have conquered in grade 10. Essentially, simple trinomials, when we use the word simple, we're referring to trinomials where there is no coefficient in front of the x squared, okay? Usually there's a coefficient of a, that's where we see the complex trinomials. But our a, in this case, is just equal to 1, so it just shows up as an x squared. And you can see that in our first two examples here, where they're just straight up x squareds. Essentially what you're looking for is we are looking for two numbers that multiply to c and that also are going to add to b. And you can do this a lot of different ways. The strategy that works well for me and that I've seen you work well with my students is to use an x to keep things in check. So I draw this giant X and I say, well, on top, I know that the two numbers I need to help me factor need to add to this middle number of 5, and they need to multiply to this last number of 4. In this case, the two numbers that add to 5 and multiply to 4 are 1 and 4. So I can go ahead, create my two brackets. And the two factors that I just found, 1 and 4, 1 and 4 are placed within the brackets. We'll do another example like that. I'm going to use my X pattern. This is really just an organizational tool. Perhaps you know something else to keep yourself organized, or maybe you can just do it in your head. That's a-okay with me. Here we are adding to -10. Remember that if there is a negative sign on either one of those numbers, you have to keep it with it. So we're adding to -10 and we're multiplying to -24. The two numbers there are actually going to be -12 and +2. I stick an X in front of my brackets and I'm going to write those two factors, -12, +2. Now you've got two examples here that are a little bit more challenging because, this one has got a coefficient that is not equal to 1. Well, remember that strategy we said first. You must common factor first. And if you take a look, we can. I can common factor out a 3 here, and I'm left with an x squared plus 4x plus 3. Now I can find those two numbers. They need to add to 4, multiply to 3. The answer is 1 and 3. And so my factored form, I'll keep that 3 up front here. It's going to come on down. But I'll have an x plus 1 and an x plus 3. It's going to be the same with example D here. Once again, I can common factor. This time it's not going to be a coefficient, but I can factor out a variable. And in this case, I can factor out an x, leaving me with x squared. Take away 6x minus 72. I'll use my X pattern to keep track of things. I need two numbers that add to -6 and multiply to -72. And those two numbers are -12 and +6. The X will be brought down with me, but now the factored form of the stuff in my brackets will be X take away 12 and X plus 6. E and F, more examples where we need a common factor first, common factor first, common factor first. In this example, I'm going to common factor out of 4, leaving me with x squared, take away 2x, take away 15. And now I need to find what two numbers are going to add to -2 and multiply to -15. That answer is going to be -5 and +3. So I'll factor my brackets to be x minus 5, x plus 3. F is seemingly simple because there is no number per se in front of the x squared. And my first term is a squared, it's nothing else. So in this case, what we're actually factoring out is a negative sign. We don't want that to be negative. In order to abide by simple trinomial factoring, the first term or the leading term needs to be a positive number. So all I'm going to do is I'm going to factor out that negative, and what that's going to do is it's going to switch all the signs for me. So now I have negative x squared take away 7x take away 8. I'll do my number chart here. It needs to add to -7, multiply to -8. The two numbers that do that are going to be -8 and +1. So my factored form will be negative x minus 8, x plus 1. Strategy number 4 is for decomposition. This is a form of complex trinomial factoring. There may be other ways that you know to factor complex trinomials, and just a reminder, complex trinomials are trinomials where you will have a coefficient in front of the x squared. It's not just equal to 1. And if you've got a totally different strategy, then that is a-okay with me. I prefer decomposition, and I find it's the most logical for students. But if you have other ways of doing this, please go ahead and use those other ways. Remember that you are trying to find two numbers, once again, that multipliers, or should I say that are going to add to b. But this time, you need the two numbers multiplying to a times c. You cannot forget the a here. It needs to be a times c. What we're going to do is we're going to split the middle term into those two numbers, and then we're going to factor by grouping. Again, this is just for decomposition. If you've got another way of factoring these types of trinomials, then all the power to you. Let's look at 3 examples here. So I have my first one, 16x squared plus 8x plus 1. I check for common factoring, not an option. Okay, so now I'm looking for two numbers that add to 8 and are going to multiply to 16 times 1, which is 16. Those two numbers are going to be 4 and 4. So what I'm going to do here with decomposition is I'm just going to keep my first term and my last term the same. So 16x squared, and then I have a plus 1. But my 8x is going to be decomposed. I'm going to split it up into a 4x and a 4x. So 8x is being broken down into these two parts. Now what I'm going to do is I'm going to go back to our second strategy, which was factor by grouping, and I'm going to say, well, I'm going to factor these two terms first, and then I'm going to factor these two terms. Of the first two terms of my yellow group here, I can factor out a 4 and an x, leaving me with 4x plus 1. My second grouping, I literally can't factor anything out. I'm just left with 4x plus 1. Now putting it in brackets to really underline the fact that both terms are the same. Remember, we had to have that common polynomial at the end. I'm going to bring my 4x plus 1 out front. And what I'm left with is actually 4x plus 1. There's an invisible 1 that's at play here. And that's what helps to create that second bracket. Well, now we have 4x plus 1 times 4x plus 1, which is this stuff being just times by itself, right? It's being times by 4x plus 1. So we can simplify this even further. We can actually just say, well, this is 4x plus 1 squared. Okay, this is truly the simplest format, the most factored format. If you were to stop here, this would be an incomplete answer. You need to go all the way. Okay, let's take a look at B. B, we're going to check, can you common factor first? And in this case, yes, you can. It is totally possible for you to just jump straight into the decomposition method or factoring a complex trinomial in any way that you want. But it's a good idea to take it easy on yourself and see if there's any way that you can simplify things. So this is one way of simplifying, is I'm going to pull out a 2 from every term here, leaving me with a 3x squared plus 7x plus 2. My numbers are smaller, they're going to be easier to deal with. Now I'm looking for two numbers that are going to add to 7 and multiply to 6. Once again, I got 6 by saying, well, my bottom number here needs to be this guy, the 3, times the 2. The two numbers that add to 7 and multiply to 6 are 6 and 1. So I'm going to go ahead and I'm going to decompose this 7x. And I'm decomposing it into the two numbers that we found, the 6 and the 1. So my 7 is being decomposed into 6 and 1. I'm going to continue factoring now by grouping. My first group that I'm going to highlight is 3x squared plus 6x. And actually, I'm going to change my first bracket into a square bracket, because now I'm going to have smaller brackets on the inside. So I factor that, or I can common factor 3x squared plus 6x, and I can actually pull out a 3x, leaving me with x plus 2. And then once again, there's nothing left for me to factor out here. All I have is an x plus 2, so I'm just going to leave that in brackets and close up my squares. I now have an x plus 2 in common, and I can fill another bracket with a 3x plus 1. All right, we'll do one more example. I cannot common factor first here. That is not possible between 3x squared minus 11x plus 10. And so I'm going to jump right into my complex trinomial factoring. I'm going to look for two numbers, in this case, that add to negative 11, and are going to multiply to 30. I got 30 by multiplying 3 times positive 10. Those two numbers are negative 5 and negative 6. So I'm going to factor by decomposition. 3x squared, take away 5x, take away 6x, plus 10. Alrighty. Across my first two terms, 3x squared, take away 5x. Not much I can do. I can take out an x, leaving me with 3x, take away 5. And across my second two terms, I'm going to pull out a negative 2, and I'll explain why it's a negative in a sec, but I'll pull out a negative 2, once again leaving me with 3x plus 5. Now, it might be easier for you to say, well, I recognize that between 6 and 10, I can pull out a positive 2. So why don't we just do it as positive? Remember that your underlying goal is for these two brackets to match. If I hypothetically had pulled out only a positive 2, I would have been left with negative 3x plus 5. Oh, and I'm just realizing I've got a typo here. This should be a negative. This should be a negative. Negative 3x plus 5 does not match 3x plus 5. And we would be stuck. There's nothing more that we'd be able to do. We need those two brackets to match. So in order to get them to match, I took out the negative. And the tip that I say just in general is if this number is a negative, I'm just going to write this in little bubbles. If that third term is negative, pull out the negative. Just do yourself a favor and pull it out. It's always best. It's going to make things easy. I promise it's going to work every time. Okay, let's finish this off before we finish off our last strategy. So I've got a 3x take away 5. And x take away 2 as my final answer here. Okay, that was our decomposition. And remember, if you've got another way of factoring out complex trinomials, by all means, go ahead and do it. Our last example here is our perfect square trinomial. We essentially have a perfect square take away a perfect square. You may also know this as difference of squares. That's another way. It's super easy to do. This is my all-time favorite, and I think many people's favorites too. Basically, you take the square root of the first term and the square root of the second term. In this case, the square root of our first term is x. Put that in the front of the bracket. Take the square root of the second term. In this case, that's going to be 3. First bracket has a plus, second bracket has a minus. Nice and easy. Do our second one. Set up our two brackets. Square root of x squared is x. Square root of 121 is 11. Add a plus, add a minus. Doesn't matter which order you do it in. Okay. In question C, we actually can common factor. So let's go ahead. We can common factor first. I'm going to pull out a 5, leaving me with x squared take away 4. And now we've got a beautiful perfect squares trinomial. X minus 2, x plus 2. D, a little bit harder. Cannot common factor first, but that's a-okay because 4 is a perfect square, so we can still use the perfect square method. Set up my two brackets. One's got a plus, one's got a minus. What is the square root of 4x squared? Well, I say, well, what's the square root of 4 is 2. And the square root of x squared is x. Then I'll do square root of 81, which is 9. So 2x plus 9, 2x take away 9. Question E, we've got another situation where we can common factor first. And I noticed that on first glance, just because 27 is not a perfect square, neither is 12. It looks like this wants to be a perfect square trinomial or a difference of squares because we've got square, square, and a takeaway sign. So we're going to try and make that work. I'm going to do so by pulling out a 3, leaving me with 9x squared take away 4y squared. Okay. Now we set up our two brackets. One's got a plus, one's got a minus. Square root of 9 squared will be 3x. And the square root of 4y squared will be 2y. So my answer there will be 3 times 3x plus 2y times 3x take away 2y. All right, last but not least, bit of a challenge question here, but technically this obeys all of the rules, right? We've got something that's squared. take away something else that's squared. Difference of squares. Okay. We set up two brackets. I have no idea how big this is going to be, so let's do them really wide. Square root of the first one would just cancel out that exponent, so I'd be left with an x plus 1. My first bracket is going to have a plus, my second bracket is going to have a minus. Now I take the square root of the second one, which again just cancels out the squared, so I'll have an x take away 6. And then in my second one here, I'm going to put the x take away 6 in brackets, and that's important to distinguish because we need this negative sign to apply to the entire bracket, not just the first term. This actually gets really interesting because of how things land. So now we can simplify our brackets, right? We can combine like terms. Here I'm going to have an 2x take away 5. This I'm actually going to, my first step is going to be to distribute the negative. Leaving me with, my x's will cancel out, and that's just 7. Sorry, let's write it better, 7 than that. And so the simplest form of this super complex trinomial we started with, is actually just 7 times 2x minus 5. So funny. Funny how things land. And that's it. We've reviewed 5 different factoring strategies. Hopefully this was useful.